Hi everybody. Already we have started the second module of theory of matrices, that is the linear transformations. In the last class, we have seen how to use the Cayley-Hamilton theorem and to find out the powers of the negative or positive powers of the given matrices. Okay, and today we are going to see what is the linearly dependent and independent vectors, and which is very important to find out the diagonalization of the given matrix. Now, testing for linearly dependence of vectors. There are many situations where we might wish to know whether a set of vectors is linearly dependent, that is, if one of the vector is some combination of the others. Two vectors u and v are linearly independent if the only numbers x and y satisfying xu plus yv is equal to 0, where x and y both are equal to zeros. The linear combination of u and v with respect to x and y, where x and y are the scalars, okay, is equal to 0. So we let us suppose that u is equal to AB, the column matrix AB, and v is equal to CD. What I mean to say that x into the column matrix AB plus y into the column matrix CD should be equal to 0. And xu plus yv is equivalent to, you can write this as xv, that is, which is nothing but a c b d. If you multiply this, we are going to get the two linear equations. Ax plus cy is equal to 0, and bx plus dy is equal to 0. So, if u and v are linearly independent, then the only solution is that the system of equations is trivial solutions. If u and v are linearly independent, the only solution for system of equations, the linear equations, is trivial solution. The trivial solution, I mean to say that the values of x and y are zeros. For homogeneous system, this happens precisely when the determinant is non-zero. We have now found a test for determining whether the given set of vectors is linearly independent. A set of n vectors of length n is linearly independent. The matrix with these vectors as columns has non-zero determinant. The set is of course dependent if the determinant is 0. So it gives a clue to find out whether we test whether the given matrix is which is obtained by the set of linear equations is linearly independent or dependent. Just we need to find out the determinant of the given matrix. If the determinant of the given matrix is 0, then that type of vectors or that type of matrix is said to be linearly dependent. I have taken an example. 5 minus 1 minus 5 2 3, okay, which is a non-zero, and we'll try to find out the determinant of the matrix 1 minus 5 2 3, right? So it is just nothing but 3 plus 10, which is equal to 13, and which is not equal to 0. As the determinant is not equal to 0, that means that these are not linearly dependent. These are linearly independent vectors. So that is how we can find out whether the given set of equations, that is the matrix is the matrix formed by the given set of equations is linearly independent or dependent, or the given set of vectors are linearly dependent or independent. Okay, so now we'll go for the another example. Show that the vectors 1 2 3 1 2 3. The another vector is 3 minus 2 1, and the last vector is 1 minus 3 1 minus 6 minus 5 forms a linearly dependent set or not. So what we need to do, first we have to convert the given vectors into the matrix form. So let us suppose that v1 is equal to 1 2 3, okay, and v2 is equal to 3 minus 2 1. and V3 is equal to 1 minus 6 minus 5. So I'll convert this V1, V2, V3 as a matrix A by writing this matrix A, and which will be equal to which will be equal to A is equal to V1. A is equal to the V1, V2, V3, and which can be written as matrix 1, column wise 1, 2, 3, 3 minus 2, 1, 1 minus 6 minus 5. Now, in order to check whether this is linearly dependent or independent, first thing that we have to do is find out the determinant of the given matrix. So I'll go for the determinant of the matrix 1, 3, 1, 2 minus 2 minus 6, 3, 1, 3, 1 minus 5. Okay, so let me work out the determinant of the matrix, given matrix. 1 into 5, 5 to 10, 10, 10 plus 6 minus 3 into 5 into 2, that is 10 minus 10 minus 10, plus 18, okay, plus 1 into 2 plus 6. So let us see whether we are getting 0 or not. 10 plus 6 is 16, right? 10 plus 6 is 16 minus 3 into, that is 8, plus 8 into 1, that is 6 into 2, 8. Okay, so we are going to get it as 16 minus 24 plus 8, and which implies we are going to get as 24 minus 24, which is equal to 0. Since the determinant of the matrix is 0, therefore A is linearly dependent. So this is how we can find out whether the vectors are linearly dependent or not for the square matrices up to order 2. Suppose if you have any other matrix with more than order 1, then we need to go for the echelon forms. Okay, so here I've calculated it 0. The given vectors are linearly dependent since determinant is equal to 0. So next, to show that the vectors 2, 2, 1, 1, 4 minus 1, 6, 4, 6 minus 3 are linearly independent. So we need to frame the vectors, we need to frame the matrix with these vectors. So the matrix, let us suppose that A is a matrix, so which is nothing but x1, x2, x3, right? And which can be written as the matrix A is 2 minus 2, 1, 1, 4 minus 1, 4, 6 minus 3. So let us suppose that matrix A is this one. So we need, again we need to find out the determinant of the matrix to check whether it is linear dependent or independent. So I have found out the determinant of the matrix, which is nothing but 2 into minus 12 plus 6 plus 2 into minus 3 plus 4 plus 1 into 6 minus 16, which is equal to minus 20, which is not equal to 0. As we got non-zero determinant, so therefore the vectors is not linearly dependent. They are linearly independent vectors. So this is how we can able to find it out. Okay. So next question we can have 2, 5, 3, 1, 1, 1. So follow the same procedure of finding out the determinant of the matrix to check whether they are linearly independent or dependent. 4 minus 2, 0, right? Okay, so I'll try to frame this equation, and now here in this I didn't go for the determinant model. I've just find out the rank of the given matrix, and through the rank of the given matrix also we could able to find whether the given matrix is linearly dependent or independent. I've just reduced the given matrix to echelon form. Okay, that means reducing the lower triangular matrices to 0, that is the elements below the upper triangular matrix to 0. So I got the rank as 2. So if the rank is equal to the number of the vectors that we are taking, then they are linearly independent. So even we can follow that procedure of finding out the finding out that means checking whether it is linearly dependent or independent. And the next, or we can go for the, if it is possible, we can go for the determinant model also, right? Are the vectors v1 which is equal to 4 1 minus 2 minus 3 0 1 v3 1 minus 2 1 are linearly dependent or independent? So again, the linear combination, I'll take the linear combination of the three vectors with some scalars k1, k2, k3. So k1 into v1 plus k2 into v2 plus k3 into v3. So that I'll try to find out, there two methods are there. I'll try to frame the matrices by using this vectors 4 1 minus 2, so minus 3 0 minus 3 0 1 minus 3 0 1 1 minus 2 1. Okay, and I'll go for the finding out the determinant of the matrix, which says if it is equal to 0, based on it's whether it is giving a 0 value or non-zero value, we can able to find out whether it is linearly dependent or independent matrices. Or else we can convert this matrix to a purely echelon form and find out the rank of the given matrix. If n minus r is equal to 0, where n is the number of the vectors that we are taking, n minus r is equal to 0, then the vectors are linearly independent vectors. Otherwise, they are linearly dependent. So that is how we can find out the linearly dependent and independent nature of the given matrices. I'll repeat once again. This linearly dependent and independent, it is very important topic in matrices because it helps you to find out the diagonalization of the given matrices, where we need the vectors which are linearly independent vectors. When we have linearly independent vectors, the diagonalization process becomes very easy. For that purpose, we need to understand whether the vectors are linearly dependent or independent. So here we have two procedures are there, one by determinant model and another by reducing to echelon form. By determinant model, if it is possible, try to find out the determinant of the given matrix. If the determinant of the given matrix is 0, then the vectors are said to be linearly dependent. If the determinant of the given matrix is not 0, then the vectors are linearly independent. So that is the easiest procedure of finding out whether the matrix is linearly dependent or independent. But only the problem is that we can't be able to find out the determinant for all possible matrices. So if you want to find out this nature for any other square other than square matrices, this method does not obey. So in that case, we can reduce the given matrix to echelon form. If you reduce the given matrix to echelon form, suppose that n are the number of the arbitrary vectors, that means that are there in the equation, and r is the rank. Suppose n minus r is equal to 0, then the vectors are linearly independent. If n minus r is less than 0, then the vectors are linearly dependent vectors. We don't have n minus r greater than 0. It's not possible. The rank will never be greater than the number of the arbitrary number of the vectors or number of the unknown values. So definitely we'll have only two options: either it will be 0 or it will be less than 0. If it is 0, then the vectors are linearly independent. If it is less than 0, then the vectors are linearly dependent. Even that procedure also you can follow for finding out the linearly dependent and independent natures of the vectors. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.